And Andrew, you're up. Thanks.
All right, thanks. I'm gonna try this slide sharing one more time. Let's see if this works. Still difficulties. All right, we're gonna go without. Thanks so much for having me, Mohammad. I'll share a little bit about myself. So my background's in research, but I've spent the last 10 years in the tech industry, focused more on practice. So most recently, I led data science, data engineering, quantitative research for Asana, which is a startup that makes collaborative work management software. I actually just finished up my time there last week. And before Asana, I led an internationally focused research team at Facebook. So I'm coming at this from the perspective of an applied researcher and data scientist whose work informed product development. I'm going to share some observations and speculation based on that experience. Also, actually, technical difficulties aside, it's great to kind of go last here and think about the themes running through some of the previous talks. I'm going to touch on some of the same ones about things about power differentials and surveillance and things like that. It's great to see these kind of coming through different theoretical lenses. So as I moved from working on a social networking product to a collaborative workplace product, I thought about what was similar and what was different. So one similarity is that critical mass and adoption is needed in both cases. So whether it's a social application or a collaborative work tool of some kind, you need other people there with you for it to be useful. But there's a difference here too, in that I believe partial adoption in a social network like Facebook is more useful than partial adoption within a team or a corporation. Facebook works fine, and depending on your perspectives on Facebook, could bring you some value or enjoyment, even if not all of your friends and family are on there. But in an organizational context, think about something like shared calendars. So they're not very useful if your whole team or organization isn't using a common platform. And similarly, it's not very useful to be able to assign tasks or track progress on a project if half your team isn't participating or hasn't even signed up to kind of see what's happening there. And another key difference, alluding back to some themes that folks have been raising through this whole day, is there are more formal power dynamics within a workplace network. So there are still social ties, but they exist in the context usually of some kind of management hierarchy with significant formal and informal power differentials. So thinking about those power differentials and the adoption of technology in the workplace, it reminded me of Jonathan Gruden's work from 1988. On why collaborative work applications fail. And I was really struck by how much his points resonated more than 30 years later. Now multi-user collaborative work software is much more commonplace than it was then. And Gruden asked some really key questions. He asked, who benefits from the adoption of a new technology? Are those benefits distributed evenly across an org chart, or are they accruing primarily to management and executives? Does adoption happen bottom up? Is it driven by people seeing the benefit of some new tool for themselves or their immediate colleagues, or is it more top down, from a mandate or a corporate purchasing decision? So Gruden frames kind of three threats to the success of this type of software. The first is that the application fails because it requires that some people do additional work, and those people are not the ones who perceive a direct benefit from the use of the application. The second thing he calls out is that the design process for applications like this fails because our intuitions are poor. Decision makers see benefits for people similar to themselves, but they don't see the implications of this extra work that it's creating for other people. And the third thing is that it's hard for us to learn from these experiences because these complex applications introduce big obstacles to generalizable analysis and evaluation. So on that third point, I think we actually can and have learned a lot more over the last 30 years about how to design and evaluate large-scale social and collaborative systems. But the first 2 points in particular still really capture challenges that exist today for people who are building these collaborative tools and those who would adopt them. So if we think about collaborative tools like Jira, Trello, Asana, Microsoft Planner, this class of tools, the people whose job it is to organize a team's work, if they're product managers, program managers, team leads, executives, they often see the value of tools like this, and they're often the people pushing their organization to adopt them. So they directly benefit from the consolidation of work and the structure and the clarity that tools like this can provide. But Like Gruden describes, it takes work from other people for them to realize that benefit. Leaders can't make these plans in isolation. They need other people, often their direct reports, where there's this power relationship to contribute something, to do a bit of extra work in learning a new tool, putting status updates or tracking bugs in there, keeping it all current. So if there isn't some benefit to the folks doing the extra work, the team might fail to adopt the tool. The benefits won't really be realized for anyone. Maybe an alternative to that is it could be mandated top down. If there's not a kind of, individual incentive, it could be mandated, but in that case, it'll probably still fail. It's just going to fail more slowly, or, in a very top down organization, maybe continue to be used grudgingly. So to succeed and to add some value for a team or organization, these tools need to serve different constituencies whose incentives are sometimes aligned, but sometimes very different or even directly opposed. So, you could consider a bug tracking tool that provides some useful reporting on software quality to senior executives, but it creates busy work for junior employees to keep it up to date. Similarly, if the junior employees, don't see a benefit for their own work, making it easier for them to work more efficiently or see their own progress or get recognized for their contributions, they don't have a direct incentive to adopt it. So perhaps we can do something like design the tool to provide some affordances, some benefits for individuals, not just management. But a starker example might be if management wants to use a work platform, as some have spoken about, to monitor productivity, while workers want to preserve their privacy and their autonomy. So in cases like this, there might not be a way to serve all the constituencies at once. And this question of surveillance is an interesting one with collaborative software too, particularly as we bring AI into the picture. So, Zeynep mentioned surveillance earlier. This is a theme that's come up in various ways. Employers already have a ton of data about employees, badge swipes, clocking in and out, all the activity on your employer-owned computer system. And this data is kind of accurate at a factual level. I mean, a key card was swiped or it wasn't swiped, a URL was visited or not. But it takes human interpretation if employers want to do something with it. So if they want to assess if an employee was underperforming or goofing off at work or something, it takes somebody looking at it and making that judgment. So even though legally and practically employers have had this ability to surveil for a long time, they haven't necessarily had the tools to kind of actively and continuously monitor the engagement or output of employees at scale. And as we move toward more and more work being in these centrally managed digital platforms, there's the potential for AI or machine learning models to monitor activity and to make automated inferences on an ongoing basis. It kind of creates new risk for employees. To use a phrase that Tressie mentioned, kind of shifting the balance of power from labor to management. This also presents risks for management. They may place too much trust in systems that are definitely not infallible. So, if they incorrectly fire someone based on an inaccurate ML model that said something negative about their productivity, that's a risk there as well. So let's pivot a little bit here and talk about, workers using AI tools to do their jobs. So we've talked a bit about the kind of black box nature of AI systems. They can be kind of inscrutable in terms of why they do what they do. And when they make mistakes, it can be difficult to anticipate them or to understand why. So as the previous panel discussed, there is research going on into explainable AI, but that is in pretty early days and not usually reflected to end users of kind of commercial systems. So we have these new questions that we need to answer for every new system or tool or process that's powered by AI. How confident are we in the outputs of the system, and what are the costs of making an error? Or even more concretely, what is the error rate? How do we monitor it? How do we manage it? If you think about, cars with semi-autonomous driving features, obviously certain errors are very costly in this context. Say you have a car that can adjust its speed with traffic and follow its lane. It sounds like it would reduce the stress of driving, but I've driven a couple of these cars and I found that it's more work to monitor the performance of the AI than it is to simply drive myself. The cognitive load of paying attention to how the system is driving and being ready to jump in and correct it if it makes a mistake is actually more than just driving myself. And the cars also in this situation might make fewer mistakes than a typical human driver, but they will make different mistakes that are surprising to a human. There's not really any chance they'll be inattentive, but there is some chance of them steering directly into a concrete barrier or a stopped truck, which a human who's paying attention would never do. In work technology, again, different circumstances or tasks might imply really different tolerances for error or different kinds of error. Certain errors could be benign, others could be catastrophic, and which is which might actually vary with context even within the same AI system. So just to take some examples, some of these have come up earlier today or in the news over the last 5 to 10 years. What if someone gets fired because an imperfect AI marked an email from their boss as spam and they missed a deadline? What if someone is denied a job or denied probation or injured or killed because of the judgments of an imperfect AI system whose exact logic is not really understandable by humans? So definitely, certain catastrophic outcomes. On the other hand, there are, benign error outcomes as well. You take autocomplete of text. If it suggests a word or a phrase you don't want, you can just ignore it. You don't accept the suggestion. So there's still some ways autocomplete could be problematic, but for a typical person, typical situation, this is just kind of a minor annoyance. So I've been talking a lot about imperfect AI. So when I say imperfect AI systems, I really mean all of them of any complexity. They're all going to be wrong some of the time. It's really just a question of how often they're wrong. And then the real question is, what do we do when AI systems are wrong? So some kind of mitigations in part. One is to convey degrees of certainty and precision through design decisions. So you have an AI system that generates estimates of project completion time for a software development team. A naive approach would be to just spit out the point estimate from the model. This project will take 19.4 working days. But behind the scenes, the system's computing some kind of probability distribution. This point estimate implies more precision than the model really has. So a better design would convey a range or use a fuzzier representation like about 4 weeks. And the principle here is just to match the precision of the presentation to the user with the precision of the estimate as, based on what we know about the model and the inputs. Another mitigation is to provide mechanisms for people to give feedback and exert control with clear results. So many systems do this anyway because the feedback helps the system improve, but it's just as important that it returns some locus of control to users. So when the system does something wrong or recommends something bad, users have a way to let it know, and they know that the system has received their kind of flag of this issue. They may feel more empowered to kind of shape its behavior over time. And I do think it's really important, just more generally, to combat the false sense of precision that statistical models like AI or ML can give us. This is true both in designing systems for users and in how we consume results from those systems ourselves. It's really easy to kind of look at precise weights and precise numbers and these confident recommendations. This is definitely a movie you want to watch and feel that this is truth with a capital T. And I think knowing that it is not capital T truth is a new aspect of technical literacy that we need to help people acquire so that they can kind of use these new tools effectively, particularly in the context of work. One other thing I want to touch on briefly is the tension between data privacy and AI capabilities in workplace tools. AI systems need so much data to be trained. And it raises these questions about whose data is being used and how is it used? What's the potential for inadvertent disclosure, for information leakage? And can we design systems to guard against it? Whose values are propagated by an AI system? These are all considerations in kind of analyzing and building AI systems responsibly. So go back to the example of autocomplete. Gmail now has had this autocomplete for a while. It's kind of uncanny how good it is sometimes. But it makes me wonder, what data was the model trained on and whose use of language, what people, what organizations is shaping what I write when I accept those suggestions. So not talking about Gmail specifically, but in the worst case that, a poorly designed system like that could leak some personal data or corporate secrets through the words and phrases it suggests. If I keep accepting suggestions, is it eventually going to plagiarize somebody's work? But even in a more benign view, a system like this can kind of homogenize language and perpetuate a kind of certain professional vernacular with core competencies and best practices and whatever other kind of business jargon becomes normalized through systems like this. So let's see, last thing I wanted to touch on, just thinking about, core competencies for educational programs and how we might kind of educate information professionals at a school like SILS to effectively kind of analyze, understand, work with, design, build AI systems. The two things that come to mind are context and ethics. Let's assume the technical foundations are kind of a given. So in terms of context, the first thing is, especially when the workings of these systems are often so inscrutable, sometimes for the builders, but certainly for users and customers, I think it's really essential to take a contextual approach to design. So people need to understand how these systems will be used, how will their users understand and interpret their output, And asking sort of what can designers and builders do to tailor the technical system to the human and organizational context of use, to really strike the right balance between the system being in control and the user being in control. Very different in like high reliability applications on an aircraft carrier versus autocomplete in your email. Very different design scenarios. And the second piece here is that it's really crucial for designers and builders to use their understanding of context to kind of reason about the ethics of what they're making, to anticipate kind of possible harms, not just technical failure modes, but as we've been hearing about, for much of the day today, interpersonal, social, organizational failure modes, and to mitigate those as much as we can through design decisions. And that includes recognizing what they simply shouldn't build. There is no way to build it kind of ethically and safely. So without stepping back to consider that context of use, I think it's really sometimes hard for technologists to kind of see past the shiny new algorithm and really understand kind of what will this do in the world in practice. But I do think that SILS and other information schools are really well positioned to teach the technical skills, yes, but also the social science, the human-computer interaction kind of foundations necessary to make these judgments about the value and the likely impact, positive impact and negative impact, kind of in given social and organizational contexts. So I'll pause there. Thanks, and looking forward to the discussion.